Hello students, this video is to go over the week 6, which is Inscribed Angles quiz, and try to explain some of the answers on that quiz if you are curious. Remember, this week was all about inscribed angles. It was also about inscribed shapes, which are shapes that are drawn inside of circles, and measuring the arcs that are associated with them, as well as the angles that are within the circle. So let's take a look. For the first problem, it did ask you to find the measure of angle AOB, and it said you can round to the nearest tenth if necessary. So there are a couple things going on here. One piece of information that was given to us is that the diameter BC is 12 inches. Since that diameter is 12 inches, I know that each of these radii, which is the plural of radius, is equal to 6 inches. Should make sense to you. Diameter is equal to twice the amount of the radius. I also am given that the arc length of AC is 2 pi. So 2 pi is the measure between A and C along the circle's edge. That's what arc length means. So we are given the arc length, and we are given the entire circumference, or the means by which to find it, but we do not know this angle. That's one thing that we can find easily by using one of the proportions that you should have learned from Khan Academy. First, let's find the circumference. The circumference is equal to 2 pi r for any circle, and in this case, the radius is equal to 6. So the circumference is equal to 12 pi. That shouldn't have been too difficult to do. For the next step, it asks us to use this proportion. And this proportion is an example of a very widely used proportion, which is part divided by whole equals part divided by whole. When you think of any situation in which you're trying to liken two different things to each other, you can use this part over whole equals part over whole formula. For example, in this case, the arc measure, which is a measure in terms of degrees, is something we do not know. We don't know the measure of this arc in terms of degrees, which is the same as this central angle in terms of degrees. But we do know that the entire circle is 360 degrees. So if we're talking about this angle here, and specifically this arc measure in degrees, we don't know it. But we're still talking about this particular little wedge. We do know, however, that the arc length, which is 2 pi, which is all the way from A to C here, that arc length of 2 pi is the part. And the whole, in other words, the whole entire circle, is 12 pi. So whatever part is represented by that small that small arc, divided by the entire circle, should be equal to whatever part that small arc measure represents for 360 degrees. Part divided by whole equals part divided by whole. Part of the arc divided by the entire arc, 360, equals part of the arc length divided by the entire length, which is 12 pi. That's the circumference. Cross multiply here, and you should get 12 times the arc measure is equal to 720. Keep in mind that these pi's were the same on top and bottom of the fraction, so they eliminate. And then we're able to solve for the arc measure, which is just 60 degrees. Remember that you should have put 60 degrees in your answer for that particular section. Now that tells us that angle AOC is 60 degrees. Well, that's great, but this is asking for AOB. So, in order to figure out AOB, we need to use another property of geometry. That property is this. If I have a straight line like BC, which is a diameter, and I have one line that cuts that straight line into two angles, then these two angles are supplementary angles. If they're supplementary angles, that means they add up to 180 degrees, which means if this is 60, this is 180 minus 60, which is 120 degrees. That's how you find angle AOB. For question number 2, it gives us only two pieces of information. It tells us that arc GY is 24 degrees, that's labeled here, and arc RM is 62 degrees, that's labeled here. Using just those two pieces of information, we're able to find three pieces of information right away. One piece of information is this inscribed angle. Since this arc is 24, an inscribed angle is going to be half that measure. Remember, we're not talking about length, we're talking about measure here, so that measure is 12 degrees. Since this is 62, a central angle that intersects that arc will also be 62, so that's where we get 62 from here. And I want you to notice that this arc, which is 62 degrees, is also being cut by this angle. This is an inscribed angle that cuts that arc, which means if this is 62, that's 31. I'm going to get rid of that only because it's a little difficult to see the rest of the problem with that there. So hopefully you were able to identify how to figure out 31 degrees here, how to figure out 62 degrees here, and how to figure out 12 degrees here. From that, we can just use our old friend Triangle Sum Theorem. I know that this is a triangle. I'm going to outline it in blue here. This triangle from T to O to R is a triangle. And I know that all of the measures of the interior angles of a triangle add up to 180. That's the Triangle Sum Theorem. So 62 plus 12 plus something is equal to 180. That means that that something, the angle OTR, that's going to be 106 degrees. Similarly, I also know that there is another triangle over here, this triangle which I will outline in red. I know that this angle is 31 already. I don't know this angle yet, the 43 degrees. I'm going to get that in a second. But I do know this 106 degrees very easily because of vertical angles. This is 106 here, so this is 106 here. Next, I'm able to use the Triangle Sum Theorem to say 106 plus 31 plus some unknown value is equal to 180, and I'm able to solve for that value. It's asking for the measure of GMO. Well, I want you to observe. Let me outline this in green instead, actually, make it a little easier for you to see. I want you to see that GMO is the same angle as G to M all the way up to T. So GMT, GMO, same exact angle. We're talking about this angle down here, which we found to be 43 degrees. Moving on up. For question number 3, it tells us that the measure of arc DE is 57 degrees. That's this arc here. Many students wanted to say that this angle is 57 degrees because of central angles. However, this is not a central angle. It tells us very specifically at the beginning of the problem that we're dealing with circle A. Since we're dealing with circle A is the center. Since there's no lines that intersect that center, I can't use central angles at all in this problem. But that's okay because we have enough information using everything else. I'm told that arcs BD, BC, and CE are all congruent. That means this arc here is congruent to this arc here, is congruent to this arc here. Seems to me that we have one arc in the circle, that's X. We have another arc in the circle, that is also X. We have another arc in the circle, that is also X. And this arc from D to E is 57. We have the whole circle here. So all of these arcs added together should be equal to 360 degrees. We know that for a fact because that is the Circle Theorem. Solving this for x, we get 101. That's 101 degrees, or Dalmatians. 101 degrees in each of these arcs. Fantastic. Now what we can do is go back and use our Inscribed Angle theorem to find a couple of these angles. For example, I know that this angle that I'm outlining in red is an inscribed angle because its vertex is on the outside of the circle. It's on the edge of the circle. Whoops, can't believe that just happened. Let me outline it one more time. So since you see this inscribed angle, which is, it has its its vertex on the edge of the circle, this angle is going to be half as big as this arc. So if this is 101, this is 50.5. Yes, it's okay to have decimals. Decimals are people too. I'm also going to outline this other angle here in blue. This angle from D all the way to C, all the way to B. That angle is also half as large as the arc that it intercepts, which is 101. This is 50.5. So now I know a couple of things. I know that this is an isosceles triangle. Fantastic. That means this and this are congruent to each other. And I know that because these two base angles are congruent. I didn't need to know that for the problem, but I could have used it for another different type of problem. One thing I do need, though, is the measure of this angle, because this angle is going to help me find this one. This angle is 79 degrees because the Triangle Sum Theorem says that all three angles added together are equal to 180. And then if I substitute the things that I know in here, the 50.5 and the 50.5, and subtract, I'm going to get 79. Looks like it was asking for the measure of BFC. BFC is this angle here. Looks like I found it already. That's 79 degrees. Moving on to the next problem, where I am given an inscribed shape. This is an inscribed quadrilateral. A couple things that you need to know about inscribed shapes. They're made up of inscribed angles, and all inscribed angles follow the same procedure where they're half as large as the arc they intercept. But we have to be very particular about what arcs we're talking about and what angles they correspond to. It says arc AB measures 68 degrees. So from here to here, that's 68 degrees. I want you to notice there's no one angle that intersects just that arc. For example, if I was dealing with angle ADC, that has 68 degrees in it, but it also has this arc, which I do not know. So I'm not able to use that right away. It also tells us that angle BAD is 86 degrees. That's going to be super important. Angle DAB or BAD is equal to 86 degrees, which means that the arc that it intercepts, this arc from D to C to B, we can call this minor arc DB, or we could call this arc DCB. That's going to be twice as large as 86, which is 172. That's where we got that piece of information. So that means this arc is 172 degrees. Not bad. Well, let's mark off the things that we know already. We know this arc, which is 172 degrees. That's the blue arc there. I know this red arc, which is 68 degrees because it was given to me. What I do not know yet is this arc. Since I do not know this arc, I can use the Circle Theorem to try to figure it out because now I've highlighted every arc in the circle. Red plus blue plus green is equal to 360 degrees. And if I add these two together and subtract from 360, I get 120 degrees. That's arc AD, 120 degrees. Now what I can do is go through all the things that I know to try to figure out what I don't. I'm looking for the measure of BCD. From B to C to D, I'm going to outline that in purple. From B down to C, over to D. And luckily for me, I have all the arcs that I need. All the arcs that I need for this angle are this arc, which I already know is 68, and this arc, which I already know is 120. So adding those two arcs together, I get 120 plus 68, which is 188. And I know that this inscribed angle is going to be half as large as that arc. So 188 cut in half is 94. Easy stuff. Now, keep in mind, it is asking for the measure of BCD in degrees. You could find this in terms of radians, and I will show you how to do that now. Now, keep in mind, you are not going to need to be using the radians for this course. Remember, I told you a couple weeks ago that radians is going to be focused on in Algebra 2, not in geometry, but just in case you decided to use the Radians formula. The way to convert degrees into radians is to multiply the angle in degrees times 2 pi over 360. That gives you the angle in radians. So I know it's 94 degrees times 2 pi over 360 equals the angle in radians. 94, I repeated my step here, stand by. That's a lot better. So it did tell us to do this multiplication, so I do 94 times 2 and then divide by 360. I get 47 over 90. So my answer is going to be 47 pi over 90. If I had to round to the nearest tenth, I would round it to 1.6 because the answer is 1.6406, etc. Again, you did not have to do this in radians. In fact, it asked you to do it in degrees, but this is just an alternate way of solving it. For question number 5, it gives us the diameter, which is 25, and it also gives us 7, it doesn't give us the 25. It gives us the 7 and the 24 instead. If you knew your Pythagorean triples, this was a very easy question. This is 7 units, this is 24 units, and I know that this is an inscribed angle, and I know it's 90 degrees. Why? 2 reasons. 1, AOB is a diameter. Since it's a diameter, this arc is 180 degrees. 2, since this is an inscribed angle, inscribed angles are always half as large as their intercepted arcs. So this is 180, this is 90. Since it's a 90-degree angle here, that means this is a right triangle. Right triangles have the property that a squared plus b squared is equal to c squared, and luckily for us, we have 2 known sides. We have this side, AC, and we have this side, CB. All we need to do is use the Pythagorean Theorem to find the hypotenuse, which is the longest side in a right triangle. So I plug it in and I chug it out, I get 25. Now, you might be wondering, why is 12.5 the answer? Well, I'm looking for the radius of circle O, so I know that the diameter is 25. This is the diameter because it's going from one point of the circle to the other through the center. And I also know that the radius is going to be half of that because the radius times 2 is equal to diameter. So 12 cut in half, this distance is only 25 cut in half is 12 and a half. All right, this video was to review the week 6 quiz, which was on inscribed angles. Hopefully this makes sense to you. Good luck studying.